Hey guys, so today we're going to start talking about doing transformations on what I call funky functions. At this point, you should have a really nice understanding of what an addition at the end of any parent function does to a graph, a negative out front, and all of that. So we're going to apply that to different functions. If you open to day 7 in your guided notes packet, we have this function whose name is f of x, and it doesn't look like anything we've seen before. It's funky. That's why we call it that. It is a function. It does pass the vertical line test. So let's go and look at our goal at the bottom. Our goal is to graph that child, negative f of x minus 3 plus 2, by breaking it into individual segments. So the first thing you're going to do is graph the f of x minus 3 part by following PEMDAS. So when we look at that, hopefully by now you have noticed that it's a translation to the right 3 units. So you take all the points that you can tell are obvious on your new function and move all of them to the right 3 units. And when you connect them in the same shape. The translation does not change the shape or size of the parent graph. So once you've moved all of your points to the right 3, connect it in the right shape, move on to step 2. Now step 2, we're going to graph negative f of x minus 3. So we take our most recent graph, in this case my blue graph, and I'm going to do the negation of it. In other words, I'm going to reflect it over the x-axis. Notice I'm changing colors. I'm using colored pencils. I'll have a lot of colored pencils available for you in class. You may want some at home as well, so that you can follow the steps. These do get messy. So I'm going to take all the points on my blue graph and reflect them over the x-axis, going the same distance away from the x-axis on the opposite side. Again, a reflection does not change shape, so make sure when you connect your points, you've maintained the shape of the original graph. Finally, in step 3, I'm going to graph negative f of x minus 3 plus 2. So I've already graphed negative f of x minus 3, that's my pink graph, and now I'm going to translate that pink graph up 2 units to represent the plus 2 at the end. Notice I'm doing this in green. When I write my transformations in colors, then I know what my final answers are. Like, that's kind of the work we show if you use colored pencils, and that's just fine. So I take all my points on my original pink graph and I move them all up 2 units. And again, we're not changing shape or size. We're just translating. So make sure you've drawn it in the right shape. And there you go. By knowing your transformations, you can take any function and find its child graph by following PEMDAS and the rules for transformations. Let's do one more. So I'm just reminding you the order matters. Again, follow PEMDAS, your order of operations. So here I have some function named g, and I've graphed it for you by itself on the top axes. It's just kind of a reference for what we started with. But on the bottom, you're going to graph negative g of x plus 4 minus 5. Again, by breaking it down into individual transformations. Here I don't write the workout for you because eventually you need to do this work on your own. So the first thing you do is what's in parentheses. I have g of x plus 4. Well, that's a translation to the left 4 units. Take every point that's obvious on your original graph and move it to the left 4 units. Again, connecting it so that it maintains its shape and size. Okay, so then I switch colors. And next after parentheses comes multiplication or division, and that negative out front is like saying -1 times. So that's my next transformation. I take my g of x plus 4 graph and I reflect it over the x-axis. So in purple now, I'm going to take my green graph and reflect it over x. Any point on x stays on x, and everything else moves the same distance away from x to the opposite side. Maintain its shape, maintain its size. The final piece of my equation is that -5 at the end. So I'm going to take my negative g of x plus 4 graph and move it down 5 units. So translation, down 5. I take my most recent graph, in this case purple, and I move all of its points down 5 units. Again, maintain the shape and the size of your graph. The only thing that will change size is your dilation. And we'll do one of those in class together tomorrow. Once you've mastered these funky functions, everything else will be easy. And that's it. Follow PEMDAS, use colors. Have a great night.